Proceeding with this paper about the achievements by RCPs and SSPs, before we move on to the recommendations and so on, let's look at some of the numbers in terms of applications of SSPs and SSP RCP combinations. Application of SSPs by primary topic of analysis. Areas of rectangles are proportional to the number of studies, so you can see different sizes here in each category. Colors represent applications of SSPs in blue shading, scenario methods in light gray here, and extensions of SSP information in light brown here. Applications include those primarily on climate impacts or adaptation in the dark blue, drivers or mitigation in the light blue here, or address multiple topics equally in medium blue, which is this one. This is light blue, this is medium blue, I guess. Okay, just like the scenarios we are dealing with uncertainties in the presentation. Results based on 1378 analysis published during 2014 to 2019 that use or develop SSPs and in many cases apply RCPs as well. We exclude papers that use RCPs only in this case. See supplementary information for methods and definition, which you should definitely do if you want more details. I'm just providing a sense. So fair number of agricultural applications keep track of these color codings, so I won't bother with it. Water, so supply, demand, and extremes. So the climate impacts are coming in through extremes there as well, and socioeconomics play into supply and demand. Other, which include various other applications, which could be fisheries, biodiversity, and so on. Health has had a fair number. Ecological, so maybe biodiversity is included here and not here. Living standards, so emissions obviously have a maybe the largest. Energy and land use, these are kind of the drivers as well that we discussed in the previous podcasts in terms of limitations of SSPs and uncertainties coming from these. Multiple topics here, and the light brown was extensions of SSP information, so regional extensions were done, population and economics and other, and then methods, those that were involved in the development were here. So it shows you kind of large number of published analyses, and there are many that used the outputs to then make several claims about the pathways, what their impacts will be on food security, water security, how the pathways may be possible or not possible, what they mean at a regional scale, let's say for India, or at various scales. And the uncertainties don't necessarily get translated when you use model outputs and then apply them locally. Some valiant efforts are made sometimes to state what was added as assumptions to downscale them in that sense to local applications, but not always, so you have to be careful as well. So here numbers of applications of SSP RCP combinations in 715 total studies applying integrated scenarios published over the period of 2014 to 2019. Each cell here represents an SSP RCP combination, with colors indicating the number of applications. So again, complicated graphic, but I won't go into the details. White cells indicate no application, so you have SSP 4 and 2100 forcing level of 7 not done at all, and similarly 7 and SSP 1. This is basically somewhere from 6.5 or so to 7.5, not done here, for example. So that's easy to track. Green rectangles along the right side of the figure indicate totals for each RCP rows here. So you have green colors here and here. Those along the bottom of the figure indicate totals of each SSP. So RCPs here, SSPs here. Unlikely SSP RCP combinations indicate those in which integrated assessment models found the outcomes infeasible under the SSPs and shared policy assumptions assumed. So SSP and SSPAs assumed. So they were given SSPs and SPAs, but the integrated models just could not meet those demands. Forcing levels labeled on the vertical axis are not spaced in exact correspondence to tick marks to improve clarity of figures. So these have been shifted. So there you go. RCP 6.0 reaches approximately 5.5 watts per meter squared forcing in 2100. So the 6 here, but you reach 5.5 somewhere here, just because of the way climate evolves. You give emission pathways, but then when you force a climate model with it, you end up with a radiative forcing that may not be exactly what you intended to reach just by assumed pathways and mitigation and adaptation along the way. Okay, so many such details, but they are all made together and translated and negotiated with the governments and presented in some final form. Draft form is released and then final form is released. Again, as we said before, decision, action, and decision, talk, and action. Are they talk, decision, action? Are they all following all these exercises? That's not always clear. So 1.9 obviously supposed to be safe and keep us below, well below 2 degrees C in that sense. 2.6 has a good chance of staying under 2 degrees C warming by 2100 with 67% or 66% probability, and then you have 8.5, which is almost business as usual. Then you have SSP combinations going into sustainability, middle of the road, regional rivalry, inequality, and fossil fueled development. So in some sense you have also adaptation challenges and mitigation challenges ranging over these various combinations. So there are unlikely SSP RCP combinations here at 8.5 and meeting these demands, but here SSP 5 using fossil fuels allows you, and obviously many simulations, number of applications were made here. SSP 2 and 8.5 has many applications, but others are lower. So models picked and chose the number of applications they made, not always limited by computational resources, but you can go and read more about the choices made. So here are the RCPs and SSPs in green here in the vertical and the horizontal axis. Quite complicated, but is the space completely covered? Are these simulations large in number as they are, and combinations of RCPs and SSPs? Do they cover the entire gamut of possible evolution of socioeconomics, mitigation, adaptation, and climate change along the way? Well, that's not easy to say, but more importantly, are these scenarios beyond a couple of decades being used for any decision making? Maybe some militaries are using them to build ports to meet the sea level rise projections. Maybe they are doing it for figuring out geopolitical hotspots in the future and so on. But in terms of things that directly apply to people, especially at local level, are they being really used? Are they usable? Are they useful? These are key questions. Let's just read some more in this podcast. Improving policy research with shared policy assumptions. Policy research is facing a growing challenge. The literature is uncoordinated, investigating a wide variety of policies with few assumptions in common across studies. As a result, it's difficult to draw robust conclusions about specific policy approaches. This idea that we can have a consensus protocol and then consensus answer from multiple models somehow represents a most likely scenario for the future is not necessarily justifiable, but At least having everybody do the same thing gives us a sense of how they can be compared, to look at how the assumptions they made and the model framework and structures differ, and what results they produce in terms of what if scenarios with warming and mitigation challenges, adaptation challenges, and so on. To address this challenge and improve the robustness of policy conclusions, we recommend further development and wider applications of SPAs. SPAs are an integral component of the scenario framework, as we saw before, describing key characteristics of mitigation and adaptation policies at the global scale, such as instruments and implementation obstacles that are not included in the RCPs or SSPs. So they are covering some things that were not completely covered by RCPs and SSPs. They are motivated by the aim of fostering common assumptions across a large number of studies to provide structure to the policy literature and allow for stronger conclusions about important policy issues to be drawn. An initial set of mitigation SPAs generated SSP-based mitigation scenarios that led to a wide range of climate outcomes. Okay. These SPAs specified the degree of climate policy coordination between sectors and regions and how it could evolve over time. They were an important factor for achievability of low warming targets in the SSP-RCP scenario framework. Okay, so combination of SSPs, RCPs, and then superpose SPAs to see the challenges to achieving the targets, achievability of the targets. With more widespread adoption of climate policy plans around the world, the use of SPAs in mitigation pathway research can increasingly be coupled to actual climate policy developments. Now, new SPAs could be developed for a wide community use, including for the policy component of proposed new reference scenarios, which we will see in the main text in the following podcasts. These SPAs could aim to address specific policy issues such as achieving the Paris Agreement goals or the implications of current or planned climate policies. We have looked at emissions gaps and so on, where we look at following current policies, where we will where it will go in terms of warming or emissions, NDCs, conditional, unconditional, and where we need to go in terms of global warming targets and so on. A continuous identification of new SPAs for policy scenarios would help the scenario framework stay up to date with the rapidly evolving policy landscape and thus keep it relevant for policy research. So you can understand, we are doing climate projections, then SSPs include socioeconomics, and then SPAs want to bring in policies, and everything is evolving. Climate response itself is not constant along the way, which the width or the spread of that uncertainty is expressed in terms of the plumes around each warming pathway and so on under RCPs and SSPs. So lots of information being combined. Does detailed representation necessarily mean increased understanding or reduced uncertainties? That's a key question you have to ask yourself. The use of SPAs has been particularly limited for adaptation. This is something to remember. Sharing common adaptation assumptions is challenging because adaptation policies are highly context dependent, typically developed at a regional level and often co-produced with regional stakeholders. All global warming is local. Impacts are local, adaptations focus on local impacts, and there is no blueprint. Even if heat wave is being dealt with in Northwest India versus Pakistan versus Afghanistan, adaptation measures or strategies are not policies, are not necessarily the same. So adaptation is hard to coordinate across regions or even within a region and at different scales. Okay. Nonetheless, a concerted effort to develop regionally differentiated adaptation SPAs could help structure learning about alternative approaches to adaptation. For example, a set of 4 alternative SPAs for adaptation in river deltas in Africa and Asia helped explore the effectiveness of alternative response options across climate and societal futures. So now we are talking about climate future and societal future policies to meet targets of mitigation and global warming and adaptations along the way. and everything is interacting with everything, so we have to be very careful. So we'll come back and look at summary of recommendations for improving the SSP RCP framework and the issues each would benefit. Then we'll look in words how these recommendations are translated in terms of specific ideas, and then the overarching question you have to ask yourself again: is this really worth continuing this methodology of projecting out to 2100 and beyond? Many models are running to 2300, some to 2500, and the models that run longer have to be simplified because the computational cost of running for centuries is very high. And when you simplify the model, what are the impacts? Do you miss something when you don't represent the internal feedback, let's say between vegetation and climate, carbon and climate, or other elemental cycles and climate, other non-CO2 greenhouse gases and climate, and so on? So many details have to be worried about, or you have to decide how much you want to worry about the details. Okay, may depend on your specific interest and your specific research area or application area, and so on and so forth. So we'll come back and have maybe a couple of more podcasts on the achievements of SSPs and then future recommendations. Okay.